Thank you for joining us. Today's research webinar is It's No Problem, Snow and Ice Control, and it's hosted by the Minnesota Department of Transportation and the Local Road Research Board. My name is Julie Swiler, and we're excited to have our presenters today, Steve Druschel, Dan Gullickson, and Connie Fortin. Today's webinar is part of the Research Radar series sponsored by the MnDOT Office of Research and Innovation and the Local Road Research Board. Each month, we highlight research projects focused on a common theme. Before we get started, I'll read the Tennyson warning. This session will be recorded for those who cannot attend. If you have enabled your camera during the session, the recording may include your image, which is private data under the Minnesota Government Data Practices Act. You are not required to allow MnDOT to use your image, and there are no consequences for declining to do so. To opt out of the recording, simply turn off your camera. MnDOT's Office of Research and Innovation manages more than 185 research projects in progress, ranging from local initiatives to pooled fund projects with other states and comprising both basic and applied research. We're here to help transportation practitioners determine whether new research is needed or if existing studies may solve your needs. Recommend the best research methodology for your project, access local and national funding sources, and manage your project from start to finish. The Local Road Research Board is a city and county-run organization that sponsors research and educational initiatives that address local transportation needs. You can stay up to date with our research by following us online and subscribing to our newsletters. We will send you website and subscription links in a follow-up email after the webinar. If you have an idea for a project or a problem that needs solving, you can send your idea to us through Idea Scale. We're accepting new ideas through April 1st, 2026, and you can just scan this QR code to access the Idea Scale site. Skip the slide and go to our presenters. Our presenters today are Dr. Steve Druschel. He's a professor of civil engineering at Minnesota State University Mankato, where he teaches capstone design, introductory civil engineering, and environmental engineering courses, and performs research related to winter roadway de-icing and surface water protection. Previous to his academic appointment, Dr. Druschel worked in civil engineering practice for 25 years. Dan Gullickson is a University of Minnesota forestry graduate with over 35 years experience working with public and private landowners installing windbreaks, shelter belts, and snow fences to better manage blowing and drifting snow. Dan is the Blowing Snow Control Shared Services Supervisor with the Minnesota Department of Transportation. And Connie Fortin is the low salt strategist at Bolton and Mink and a nationally recognized leader in chloride reduction strategies. Her work bridges science, design, and policy, empowering engineers and decision makers to implement sustainable, low-impact solutions that reduce chloride pollution at the source. Please note that we will have time for questions after the presentations are complete. I'm now going to turn it over to Steve Druschel, and I'm also going to bring up his presentation here.
Thanks, Julie.
I want to make sure I got the right one here for you, Steve. One second, please.
Oh, Jed and I only look alike.
Okay, let me go
No
to
way
this
do I
one
move
here.
as fast as Jed. Yep.
Let me grab this up here.
There we are.
Great.
So I'll just start jumping. So
Okay.
this idea of de-icing into the very cold range, it's very timely. This came out of frustration that MnDOT had with road conditions that occurred in the polar vortex of 2020. A lot of money and a lot of labor was put into recovering roads, and frankly, probably a lot of pavement damage occurred in that because it was a wet snow that preceded the front moving in, the vortex moving in, that then the temperature just sunk and dropped probably about 55 degrees. The wet snow had landed during the evening traffic and bonded to the pavement very tight. And before MnDOT, in many spots before MnDOT could come back and take it off, it froze on really tight. So they were frustrated. There are products out there, but they don't have the science developed with them. And we don't really know how to evaluate dosage very well. It's really a guessing game. So there's money on the table in guesses that are overdone and too much. And the idea was, could we find ways to characterize it better and improve the performance? So next slide. There we go. So we started with the selection, actually it started with the selection of the product. We do not promote this product, V-Heat, we just evaluate it. And I say that both from my institution, Minnesota State Mankato, but I also say that from MnDOT. The TAP evaluated what was being used across the state, and widely used in most districts was V-Heat. So it was selected. Our first task was to collect samples. We collected from across the state, trying to get a variety of delivery and tankage situations, but also delivery times. We looked at old material from the previous year and new material being delivered. And we looked at variations in it. It does vary a bit, mostly related to how the tankage is kept, how the liquid is kept in a tank was what we found. But it's high in dissolved solids, probably about a 30% dissolved solids. If you evaporate it all, it takes a long time, but it will turn into basically a hockey puck. But that said, you could run one of those 5-gallon buckets through your fingers and have nothing, no solids left at all. It's a unique material. Next slide. We started with lab work, going much more into it. This is what you're looking at, is determining the freeze point of the material. That's extremely helpful in figuring out how it will perform in the field. To do that, we had to make cold baths. Freezers only go to 0 degrees, regular commercial freezers. Scientific ones are really expensive, more than a state university should buy. We have a technique, we've been using this for about a chilled coolant material on antifreeze. It's yellow just because it's ethylene glycol. And we would chill that down. It would take days to chill it. And then we would use that hopefully as a slush in a solid liquid state, and as crossing over, it'd be very stable. We could hold temperature for 2 days. And so here you see it performing at -21. All the test tubes or the vials are containing mixtures of bead heat, and you see in the picture 20%, also known as 80-20 in the way it's described in the field. That's 80-20 that's now frozen. And so, okay, we're below freeze point. Next slide. This produced an interesting curve. There was some uniqueness. This is a composite curve. On the left is sodium chloride in the dotted, that's taken from previous research that we did. And then the dark line is what we determined. Notice the break, because what happens is as feed heat goes and we find it, we chase its freeze point out based on the concentration of the mixture, we find it flattens. It doesn't, if you go 100%, it won't freeze down to -34 and beyond. We got to -40 for a while. It wouldn't really freeze. That point is just a holder. And we found it can really go places. This is exciting and really helpful for Minnesota. This whole graph is a composite based on the mixture with the base, when I say 80-20, 20% beet heat, 80% salt brine. So it's the assumption of the amount of salt, sodium chloride, in the mixture, as well as the beet heat components as total dissolved solids. Next. So the ice melt capacity, we do a lot of these. I think we did about 800 of these tests. It is a test of how effective the salt is. How much does it melt for a given amount of deicer? How much does the deicer melt of the snow and ice for the amount of deicer put on? Do you need to throw more, or could you do less? And you see, again, tests at -11 in this case. It gets strange as you get colder. Go ahead. I'm not a physical chemist. This isn't, I'm an engineer. I'm a wide person, wide lens person, not a molecule person. Next slide, Julie. And so the ice melt capacity, we create little freeze coupons in those cups. Those cups are sitting on a plate that has been frozen at -35. And so we are able to hold temperature. Those cups are out of the cooler for less than 45 seconds to maintain the chill on them. The de-icers put on, we measure it with a syringe, pull out the amount, and then at 30 minutes, redistribute it. At 60 minutes, redistribute it. At 90 minutes, redistribute it. The total test is a 2-hour test. This generally conforms to a test standard, but it's not a tight test standard, and there are issues with this. But it's a method we've been using. We find consistent results. Go ahead. And we get an ice melt capacity curve like this. On the bottom, you have temperature, from high temperature on the right to low temperature on the left. And going from the vertical axis, you have no melt at all. Really, the material freezes, the liquid freezes, to a very high melt capacity as it rises. And you can see with warm temperature, we get a lot of melt with our de-icers. Get down to about 12 degrees, and all of a sudden we're getting some. But then as we go, it flattens out and we get to an ice melt capacity of 1. That means it's just basically sitting there, not producing liquid. The blue dashed line is salt brine. By the time you get down below 10 degrees, salt brine is now into refreeze. Refreeze takes longer than this test. It's slower than melting by about a 4-fold factor. And so it's in process. In the 2 hours of the test, basically refreeze is occurring. We're getting a small number there. Notice the red line, the red dashed line. That's 100% beet heat. It's not recommended to be put down as 100% on the roads, but it's telling to see that even 100% beet heat doesn't shift this curve very much. And that's been a unique answer. It's like, should we use 90-10 or 80-20 or 70-30? Maybe it doesn't matter. So let's go to the next slide. Field tests are the real tests. Let's go. So Camp Ripley, 160 miles north of here, middle of the Minnesota National Guard Training Center, has a 2.5-mile test track and a 10-acre skid pad. The conditions for the field work was it had to be less than 10 degrees last year. We were waiting and waiting and waiting. You also need snow. And when the snow and cold arrive, we're going to prepare and create compaction of stuck on snow and ice, and then test in actual highway configurations. Go ahead. So this is a testament to field research. The labels you see, the picture is of the test track off of Google Earth. The labels are the best laid plans agreed upon by all the parties involved, and off we go to the field, and snow did not cooperate. It had blown off for the wind. We talked about that earlier in an offline conversation. And you see, as you always go into the field with a big purple marker, because the WB1, WB2 and on is a in the moment recast of our figures, of our testing spaces. It was rough, but it was a way to recover, and we had a lot of people and a lot of arrangements, and this was our only shot for the winter. Go ahead. People say research is sexy. Okay, so this is what it looks like. This is the test pad. You see 5 of the 6 trucks lined up. We plowed the lanes for them. They're side by side and separated by the windrow to keep cross-contamination, cross-treatment from going on. Go ahead, next slide. You see one of my student workers. These are undergrads, by the way. That's you're seeing somebody wearing $1,400 worth of gear to be outside on the ground, 8 hours on the ground at 9 degrees. And the plow truck is down. It's not plowing, plows up, but we're treating the plowed surface. on it. And it's, in this case, it's a spinner plate, left wheel line drop onto the chute. Go ahead. And then we test. And test is also not very sexy. It looks like this in the winter. You go out and you actually touch it and test it. We do a lot of photography and comparison of photography, which I'll show you in a minute. But you also have to be up close and pushing and touching and seeing the snow strength. That's the real question. Go ahead. So we have the outer perimeter test track, 2.5 miles with 8 sections on it. We plowed off the snow. The snow had been wetted. We had taken a tanker truck with brine to wet it along the way. It's too cold for the brine to work, so it created refreeze, and it gave us some body to the material, trying to stick it down to the pavement. But then comes the time, we plow it off. Go ahead. And then we treat. Again, left wheel line treatment. You see the liquid of the beat heat coming and dropping on the spinner plate along with a fixed amount of the rock salt. We know the rock salt will not be effective at this temperature, but what it does is it's the carrying agent and helps to grind in and spread the beat heat, is the theory. Go ahead. And so this is traffic. We put traffic on the loop. We put 15 vehicles circling every 7 minutes. Go ahead, push one. We should get a video. Nope. Okay. Anyways, that's the I called that the Indy 500 for the 32-mile-an-hour set, because the trucks are going by. We have all our safety gear on, and my photography crew and I are there taking pictures before and after, documenting the change as it goes. 2 hours those people drove in a circle at 32 miles an hour. Bless their souls. Go ahead. And so now let's do 4 or 5 slides in a row. This is a shot of treatment. You can see it. It's the direction of treatment is into the slide, and it's left wheel lane of the left lane. This is a 2-lane highway looking across. You can see right where it dropped. That's 30 minutes after treatment. Go ahead. And that's the same location 50 minutes after. You can see a widening out of the treated area. Notice the brown, that's the beat heat that's on the snow. It's getting into the adjacent areas, and we're seeing pavement open, but we're seeing a lot of softening. Go on, go ahead. And it's wider. Now we're losing our open pavement because we're getting mixing in of the slush that's been created. Again, this is all at 9 degrees. Go ahead. And now you see it at 95 minutes after treatment, and it's opening. It's kind of pulsating a little bit, moving around with traffic. Traffic's weaving in and out, trying to be as real as they can be going by, and we're seeing effects. At this point, it's pretty much stable in what it's going to do going ahead. All right, next slide. The interpretation of this is that all this work is above 10 degrees. Salt brine works just fine. Stay with that. It's cheaper. Below 10 degrees, though, alternative deicers might be necessary. And you're adding ions, and then so we can get into the physical chemistry, but a little bit of that goes a long way. The idea is the more ions, the more you create melt. But we don't see the melt on this. We see it softening. Softening is the word we're emphasizing here. One of the phrases that came up was, it looks like a Diet Coke slushy, maybe. Time and traffic make a huge difference. The spreading and blending magnifies the effect of the softening. It spreads sideways across the roadway. And of course, the old phrase, let the material work. Absolutely don't plow off too soon. Let it penetrate, let it get in. It's getting into the crystal structure of the ice on the roadway. We don't want that to be happening in the ditch rather than the roadway. Pavement temperature is, of course, key. We've known that for decades, not air temperature. Sunny skies, higher sun angle make midday, afternoon applications preferable. Absolutely. Morning is possible and okay because you get the rising sun. Evening after sunset is pretty much, you're not going to get that. You can get up to a 10-degree difference on the pavement because of a warm sun, particularly in February. The tankage and the storage capacity may actually control how much is applied, because trucks can only carry so much. Even though they're loaded with saddle tanks and center tanks, they still, it's on the long routes, may have to reduce the amount. It's an issue. Go ahead. We took this on tour to the around the state, to all the districts, and talking to the maintenance supervisors. Got a lot of feedback, a lot of strong opinions from people who really care. It was very, very helpful, even though they seemed really angry. They weren't. They were just like, They've got pesky drivers. They've got budgets that are smaller than they want. They've got roadways that don't behave. It was amazing to talk to the frontline people. And then we took it to the Quad States meeting as well. Go ahead. And this is our graph that we developed over this conversation. And we're trying to develop this into an easy tabletop product now that'll go with the report. Temperature on the bottom, same way, from warm to the right to very cold to the left. Ice melt capacity, as we talked about, increases vertically. You see that ice melt capacity curve we developed for beat heat on at different amounts. The zones are what we're trying to point out here. Above 12, 15 degrees, salt brine works just fine. Just stay with that. It's melting range. But below that, it's transitioning into softening range. And with the beat heat application, we can get softening and it will be plowable. It may not melt, but it will be plowable. And that's a big gain. Below that amount for putting on material, we don't get melting, you don't get softening, it'll stay there. The material will just sit on top. Go ahead. There are a whole lot of people that helped with this. I want to thank them very much. I don't even have my student workers up there. And it was a really big team project. And we're going again. We're gearing up. We're going out next week. Right now, most likely go no-go decision tomorrow. But it looks like we'll be out there again Thursday, Friday. Sorry, Wednesday, Thursday. Hope I get my days right. Thank you. Go ahead.
Thank you. We'll move to Dan.
Good morning, everyone. I'm going to get ready here to pull up my PowerPoint here. Bear with me here. Let me know if you can see my screen, Julie.
Yep.
Real good. Well, I am going to talk about a research project that we did with the University of Minnesota, and it's promoting snow fence engagement. And with that, Simon Sinek is an American author, inspirational speaker, and he's a leadership expert. And he talks about the concept of starting with why. In his book, Start With Why, he states that people don't buy what you do, they buy why you do it. Today, I'm going to talk about why MnDOT uses snow fencing. Snow fencing can be very successful, but it oftentimes requires us to work with landowners so we have the sufficient room to capture and store the snow safely, keeping the snow drifts off the highway, helping us to get to our destination, especially when we have these windy events like we've been experiencing yesterday and even today. There is a human toll, and this is the why, why we're looking at snow fencing, and even the stuff that Steve was talking about and Connie's going to talk about later. It's helping to reduce those crashes that can have lead to fatalities. It can have, severe life-altering type of injuries. And over the last 4 years, 18% of all of our traffic crashes were tied to snow and ice. That's like 62,000 crashes, 803 severe injuries, 198 fatals. What we found is where we looked at where we've deployed our snow fencing, we were able to reduce crashes by 22%. So it is a tool for managing the wind and helping people get to their destination. Also looking at the why in terms of snow fencing, road closures, travel delays. When state patrol or our own maintenance crews have to be directing traffic, they're in harm's way during those wind events, getting struck from behind. or other vehicles that lose control. And so helping to put them in a safer zone so that they can have better visibility in where they're working. This is where snow fencing can play a role. You know, mechanical snow removal back in the 1970s, you know, more heavy equipment was being developed. And, you know, we started to really get out of the idea of using snow fencing in the 70s, trying to muscle our way out of it. One of the things we're learning is that, you know, we can't be everywhere at once, and where snow fencing could be beneficial with helping reduce the need to bring in this extra equipment. The other thing is in the 1970s, we didn't have real good guidance in terms of what would be an effective snow fence, and that has improved through the years. And then also the benefits of mechanical snow removal is, you know, it's difficult getting landowner buy-in and support for taking farmland out of production to place a snow fence. And so, you know, mechanical snow removal is key to keep those roads open. The trapping of snow is an opportunity to save and managing the wind to help reduce our salt use. This is a series of snow fencing, structural snow fencing along Interstate 94 near Moorhead. And along that stretch, and it's about 6 miles, we have found a 40% reduction in salt use. And you can also see, you know, what it looks like from the plow camera there, helping that road salt be more effective because you don't have all that wind particles and all the snow particles being captured by the wind sifting across the road, cooling that pavement and compacting in there. So it really does help reduce some of that chloride use. You know, I want to acknowledge the research efforts of Dean Current, Gary Wyatt, Aidan Reed, Ayrton Sierra Jr. They're with the Center for Integrated Natural Resources Agricultural Management. Dean was the principal investigator, and Aidan did a lot of the landowner engagement and outreach. And this project happened during COVID, and so, you know, there wasn't the opportunity to meet face to face. And so Aidan had to really develop some innovative ways to contact and communicate with landowners who would be interested in sharing their stories of what they did, what we can learn from them who have actually done snow fencing. And so there were 30 landowners that participated in this. And I also want to extend my gratitude for the Research Technical Advisory Panel, Ann McClellan, Anthony Carlin, Brian Christensen, Denny Moline, Julie Gretsch, Steve Doles, and Trent Robbins, and David Glyer, who served as project coordinator with MnDOT's Office of Research. And so the different types of blowing snow control treatments that landowners have worked with MnDOT on are standing corn rows. Standing corn rows, there were 9 landowners that were interviewed. Standing corn rows are the gateway to actually doing a longer term fix. We enter into an annual contract with the farmer. At harvest time, the farmers pick the corn in their field, but they would leave a 30 to 60 foot wide strip of corn, offset a sufficient distance from the highway to reduce the blowing snow. MnDOT enters into an annual contract with them. We pay them in April of each year. And it is an opportunity to see if, you know, hey, this system works in terms of managing the snow without making a big investment in a living or structural snow fence. And it can be a gateway to adoption of maybe even a longer term fix. But standing corn rows is a tool. There were 18 landowners that were interviewed who had done a living snow fence. Living snow fences are combinations of trees, shrubs, and grasses. And sometimes we incorporate native grasses and wildflowers in the snow catch area, that drop zone, which can be good for erosion control, pollinator habitat, grassland nesting bird habitat, those other environmental benefits. There were 3 landowners interviewed who did structural snow fencing. Structural snow fencing consists of a flexible composite rail with steel fence posts and steel sleeve foundations. The fences come in 4, 6, 8, and 10-foot tall heights. Each fence post sleeve foundation is 2 feet longer than the post height itself. Thus, there is more steel in the ground than above ground to support these snow fence structures. So what did we learn? Well, we wanted to find out what motivated these 30 early snow fence adopters and why they installed snow fencing on their property. How were they impacted by the snow fence? What advice they would give others who are considering adopting a snow fence, and what advice would they give our snow fence designers, maintenance staff, and project managers? Now, keep in mind, these are the motivations of the early snow fence adopters. Simon Sinek mentions that the early adopters account for about 13.5% of the population. And these people were motivated in making a difference and are not afraid of being the first to try something. And so what did we learn from them? Number one, they were most interested in public safety, transportation, looking at reduced crashes, improved traffic conditions, and a sense of civic duty. And many of these landowners lived in the same vicinity as where that snow fence was, and they may have also personally benefited from that. Financial compensation. They like to see they looking to be compensated for their land that's taken out of production, the inconvenience of working around it, and that if there's easements acquired, that the land not be taxed in the future as productive farmland because it could no longer be put in production. And then conservation was third, and it was only brought up by those who had installed the living snow fence. That would be the trees and shrubs. They had an interest in improving pollinator and wildlife habitat, as well as the aesthetic appeal of the trees and shrubs. I think the key here is not to assume that these motivations reflect the motivations of the majority of the people out there, of those who have not previously installed the snow fence, but these early snow fence motivations may help us cross the chasm for gaining greater landowner snow fence participation. So one of the things that we looked at in interviewing them is what did it have in terms of impact on their crop yield? And 69% of them felt that it did not affect their yield, whereas 31% of them thought it may had an adverse impact on their crop yield. The other question is, how did it impact their start of their planting season? Overwhelmingly, 85% of the people felt that it did not delay their planting season, whereas 11% thought there was a slight impact, and then 4% was also concerned that there was a delay, and that could maybe be tied more in terms of if it was the standing corn rows, in terms of the hassle of having to go back out there with the combine in the spring to move that corn. That was one of the things that they're looking at. And so that also ties in with the impact on equipment and labor, the various snow fences. And 81% of them felt there was no impact, but 19% felt that there was a greater impact. And that was especially held true with those who had done the standing corn rows because of having to get out there with the combine in the spring and pick that corn they could have picked in the fall of the year. As we look at the labor impact, it's all, it's pretty much a third, a third, a third. And a lot of that is tied to, whether, if with a living snow fence, you're going to have to water and care for those new plantings. You just can't plant them and walk away. So there is going to be an impact in terms of labor and time spent caring for planting. As well as with all the practices, there's the various equipment that's used for, mowing and spraying and weed control. So in terms of financial compensation, the data was really only really good for those who had done living snow fences and standing corn rows because we only had 3 participants who'd done the structural snow fence. Didn't really feel that we had a good data set to see how they felt the compensation was. And especially with the one landowner who we didn't actually pay him directly for the snow fence because he had bought the farm field with the snow fence on it from another landowner. So there really wasn't MnDOT compensation given to him as a result of his purchase. But overwhelmingly with the standing corn rows and the living snow fences, though, 81% of the people felt that they were adequately compensated. The 19% that maybe didn't feel that they were adequately compensated, could be tied to the, the hassle factor of having to go out there and get the combine out in the spring, or also the, the do the weed control and the mowing and the things to get the planting to grow. So what advice do these early snow fence adopters have for other landowners? Number one was keep an open mind. Talk to other landowners who have adopted snow fencing. Have a MnDOT contact walk you through the process to help it go smoothly. Have a clear maintenance understanding on who takes care of weeds and the snow fence itself. And that's something that we're continually looking at how we can improve that. This is an opportunity to diversify their revenue stream. Instead of just making money on corn and soybeans, also being compensated for their land that could be holding snow or storing snow with the snow fence. Recognize the community benefit that you're doing is going to be greater than just the financial benefit. And get ready to receive lots of positive feedback. A lot of them commented on that their neighbors would comment, how well their snow fence is working. And what advice do early snow fence adopters have for MnDOT? More consistent MnDOT staff. A lack of continuity presents frustrations and prevents a stronger professional relationship from developing, because there might be different folks that are talking to them during the process. It's good to have like a consistent MnDOT person, a project manager that's talking to them, so that they have one person that can help guide them through the process. Hearing from MnDOT how effective the snow fence has been. Many of these snow fences, especially the living ones, have been in play for 20 years. And MnDOT really hadn't followed up much with those landowners to let them know, what, we appreciate what you're doing. This is how much it's helped us reduce our plowing or having to bring in that extra equipment. Also looking at, did it help reduce crashes, reduce salt? Having just a conversation with them, follow up to let them know that we appreciate their efforts and just, what kind of difference did they make? Looking for flexibility in the design process. With the living snow fence, some of the landowners commented on, what are the shrubs, the trees, the types of species that are being used, and looking for flexibility in terms of some of those plants. And then compensation, being compensated for their land that's being taken out of production and the impact to their operation. And then developing a continuing management plan for aging snow fences. What is the strategy when these snow fences get to be a certain age in terms of replacing parts or having to go out there and do some rejuvenation work to get them back in a state that they're going to be working well. So in summary here, in conclusions, there were 30 case studies were conducted, and they represented a geographical area across the state. Landowners are constrained by the lack of knowledge on the real and perceived inconvenience of installing and maintaining and farming around a snow fence. And landowners want more information about the issues involved with snow fence installation and maintenance from a trusted source, a peer, or a testimonial. And so one of the products that they developed here is this Farm Maps tool. And if you use that farmmaps.umn.edu, it'll take you to a site that will see testimonies from those landowners. We got drone video and pictures of the various snow fences that are out there, living, structural, and standing corn rows. And just an opportunity to hear from the farmers and landowners what it was like to do a snow fence. And with that, I thank you for this opportunity.
Thank you, Dan.
All right, looks like I'm up. All right, you can see my slide, okay?
Yes.
Okay. Well, thanks everybody. I'm Connie Fortin, the low salt strategist at Bolton and Mink. Prior to joining Bolton and Mink, I owned Fortin Consulting, and I spent several decades working with the maintenance crews, trying to move us towards a more precise industry. And really in those 20 years and being in front of so many of the maintenance crews, they taught me more than I taught them. So I'm just happy to be here today, and also just wanted to say Stephen and Dan's work is really great. I admire their work, and just it's like a play day for me to be presenting with them today.
Connie, can I interrupt you? We're seeing your presenter slides.
Oh,
If you can click
okay.
on maybe on your
Let me see.
display settings, you can switch the perhaps.
Let's see here.
There you go.
How's that?
Great.
Better? Okay. So I first want to start by saying thank you to all the people that were part of this project. Ryan Thelgis from Blue Earth County, it was his idea to create easier insight for the maintenance people on the brand name products, the de-icers. David Glyer was our project coordinator through MnDOT. We had TAP members representing cities and counties and MnDOT. And then we brought in some specialists, more chemists, because what we were asked to do is to sort of characterize the chemistry of a variety of brand name de-icers. So that was sort of an unusual ask, but they were willing to donate their time. And then we had a team back at Bolton and Mink that all were involved in this project in one way or another. Oh, got here. Okay. So the project goal was, how do we help the maintenance leaders make decisions on brand name products? They don't have time to go out and read all the research and study it. They are being faced with, here's all these different products we could try. And they just wanted sort of a cheat sheet that says, hey, what's current? How do these things work? So we can make an informed decision. So the project goal was very clear. As our team got assembled, we had 3 tasks to do to start off. First, the MnDOT librarian or library services gave us a giant list of literature that they thought might contain some clues as to how these name brand de-icers work and the different characteristics that we were going to investigate. But to keep it within the budget and the timeline, we wanted as a group to reduce our literature review to 50 pieces of literature. Some were very long pieces of literature. So it was important for the TAP to look at that list, cross off the ones they thought were old news or not relevant, and add in what they thought would be better. So we went through this process. We eventually all agreed on what 50 pieces of literature we were going to review for this project. Our next task was, which brand name products do we want to investigate? So everybody brought their list. We eventually agreed as a group that these items on the right of your screen were going to be the products that they wanted to know more about. And then our last challenge for the group was, well, what do you want to know about these products? There's a lot of different characteristics that we could research for, but to keep it within the time and the budget, we are going to choose the 10 characteristics that are most important to somebody running a maintenance operation. So we looked at relative cost, ice melt capacity, ice melt speed, practical application temperature, infrastructure impact, impacts to water, impacts to soil and vegetation, optimal conditions for use, the product experience by the users, and the supply chain robustness. So that's what the group agreed. So this took quite a while, as you can imagine, especially as we added in our chemist to the conversation. But then we had our marching orders and we set off to do the research. We got maybe 2/3 into our project, looking through these different documents, looking for these brand names, products, and looking for the characteristics of interest to our TAP. And we just could not find enough published data on the brand name products. So we came back to our TAP and we said, look, if we continue our project this way, we are going to have nothing to report because the data is very spotty. So what should we do? Our researchers had been keeping track of generic chemical references and the characteristics of our interest for this study that applied to the generic products in addition to the brand name products. They weren't asked to do that, but they did that anyhow. So when we got to about 2/3 of the way through our literature review, and we hit kind of that brick wall, we suggested to the TAP that we could change our goal for the project and switch it over to doing the generic products and the 10 characteristics of their performance. Now, this has been done in many ways, across the de-icer research platform. But we thought if we did that, concentrating on the characteristics they are most interested in, and if we mapped it back to these brand name products of high interest, perhaps that would help inform our users. So the TAP and MnDOT and LRB agreed to give us I think it was a 6-month extension, and we added in a little bit more funds to fill in some of the gaps since we switched directions. But in the end, we've developed a fact sheet. It's just very easy to look at and understand, and I'll show it here, where you can see on the left column, we have those brand name products that were of highest interest to our technical advisors. And then across the top are the generic chemicals. And wherever you see an X, one of our brand name chemicals contain a generic product. Now, we know that the concentrations can change. These are approximate. This is the percentage at the time of our research. And that there could be other like secret ingredients that were not disclosed that are not on our chart. But at the very minimum, somebody interested in one of these generic brand name products can see what are the major components. And then on the same fact sheet, you can see our 10 characteristics of highest interest: ice melt capacity, speed, optimal conditions for use, relative cost, and so on. And we scored it. Now, scoring these things looks easy, but it's difficult because it can misrepresent. But the TAP kept coming back to, look, our truck station leaders, our maintenance leaders want some quick information that gets them in the ballpark. And so even though it's not perfect science, it's simplified science, they felt that this would move us further ahead. So we put this together, and you have these 2 links here. You can take a screenshot, or maybe we could put these in the chat. So the de-icing products user guide fact sheet is what I showed you. It has that cross-reference between the specific brand name products and their generic components. And then the characteristics of these products of highest interest to the committee and how they scored. We also developed a de-icing products user guide. So what that will do is it will give you more details about our research and how we came upon that scoring. Why would we give something a high or low rating? What does it mean? And so if the user was a little bit unsure, like, I think I need to read a little more about this, we've put this together to support the fact sheet and to support you in your decision making. So I'd just like to thank MnDOT, LRRB, our TAP committee members, and all of you out there. First off, for wanting the research, for using the research, and for doing such a good job in winter maintenance. It is a very difficult job. It's an industry that's in change. And I feel encouraged every day that we are moving ahead, and Minnesota is really doing a good job in a leadership role here. So I will stop sharing and turn it back over.
Thank you. Thank you. Thank you to all of our speakers. Very interesting subjects today. We do have time for questions, and feel free to put a question in the chat or raise your hand and we will unmute you, and you can ask your question. I'm going to go through the chat here. The first question is for Steve, and it's from Steve Cook, who is asking, is there a different effect on vehicles and their components with the use of beet heat added?
So that begs the question, would it be on the delivering vehicles or on vehicles around? So probably it's somewhat the same. You do have problems. You'll notice Connie pointed out beet heat. It's called beet heat Minnesota. Mag chloride has been taken out of the wider used beyond Minnesota, beyond Iowa, I believe too. Beet heat, because there are issues with gelling in the line at certain temperature ranges. I haven't seen that, but I've heard about it from the crews. But more likely you're going to sense corrosion issues with it because it's carrying a lot of dissolved materials. And the issue is it's probably not worse than any of the high strength de-icers with mag chloride, with calcium chloride on it. But it's in the same range. It's different than sodium chloride. And what's particularly different about it is it's carrying all those sugars and carbohydrates. So that has been seen to have an issue. If you don't wash your trucks, bad idea. If you don't wash your trucks, you're going to get material drying and sticking on. It becomes like sticky toffee. It actually smells like brandy when it ages. And it will end up putting corrosive material very close to metal on it. And so that might be the biggest impact. Wash your trucks, wash your cars.
Thank you. We have another question for you from Carolyn Dindorf. And the question is, with the minimal difference between 70-30 and 80-20, why did you choose 70-30 for your field test? The results seem to indicate that it would work just about as well to go with the less expensive 80-20 blend.
It was a field call. We had planned it out. We had 6 different blends there, including from salt brine to 100% beet heat. And we chose 70-30 to lean on a little more oomph was the hope. We didn't see it because we did have side-by-side comparisons of the material on the pad, but we hadn't seen that yet. We were trying to sort of fuss that out. And that is actually part of what we're going to do next week, is a little bit more of that. The cost difference between 80-20 and 70-30 is not very much. I don't have that figure right at hand, but I do have the figure. Beet heat 80-20 compared to salt brine use is about 55% more expensive. But the issue is That's just product cost. Your application costs are the same, and then you have to put it in perspective of what's the crew time and equipment if you're trying to put down a material that just won't work. And you have plowing, but you have no de-icing going on under 10 degrees. So the cost is deemed very much worth it, because in the long run, you're saving route time, you're saving labor time, and you're saving crashes.
Thank you. Question for Connie from Andrea Weber. Were environmental impacts of use of salt and alternates considered in any of the analyses? I only saw infrastructure and corrosion mentioned. So the amount of salt mixed has environmental impacts to ponds and wetlands that are nearly impossible to mitigate.
Yeah, in our research, we called out impacts to water, soil, vegetation, and infrastructure. So that if you look at that fact sheet, you will see sort of a scale of, high, medium, low, that type of thing. And then if you looked at the guidebook, you would get more insight as to how we set up that scale and what it means.
And I'll just say that the questions come up a couple times. We will be sending out links to all this information in a follow-up email, along with a link to a recording of this webinar, so you'll have this information in hand. Another question from Chris Dedeen from Steve. How does that beat heat compare to using treated salt? Or perhaps it's for either of you.
So much of the salt right now is treated, pre-treated with what's called it's not really, the terminology gets difficult with field people. You got to verify these carefully. It's a stockpile treatment. Typically it's 4 gallons per ton. And what they're putting down liquid wise is 20 gallons per lane mile. To work the math out a little bit, the 4 gallons per ton is about 1 gallon per lane mile, if I remember right, maybe even a little less than that. So it's much smaller, yet we have heard positive results from just that. So we're going to be testing stockpile treated rock salt next week. We didn't look at it. It's done mostly to keep the salt loose and moving, and granular, stop getting salt boulders build up from just the humidity.
Thanks. Question for Connie. Potassium acetate looks like it has the least harmful, this is from Carol Zoff, by the way. Potassium acetate looks like it has the least harmful effects for vegetation and water, but does it control ice well? Can you comment on the cost as the limitation for wider use? Seems a limitation for wider use.
Yeah, I'll just say generically, the acetates are a manufactured product, sort of, can think of like a vinegar or something. So the cost to use an acetate versus a chloride product is generally significantly higher. So I guess I'll just leave it at that.
Thanks. I have a question for Dan. I'm curious, in snow fence adoption, if it helps to have one farmer see what his neighbor is doing, who might have a snow fence. Does kind of throughout the community, are there discussions, or does that make it easier to adopt if you see your neighbors using it?
Yeah, great question. Yeah, great question in terms of, landowners talking to landowners. There's probably definitely like the coffee shop talk that might be happening at the local cafe or at the various, the farmer's elevator, that type of thing. So I think that's definitely a real thing. And so, I think the thing that we heard with those early adopters is, they heard from their neighbors that maybe they saw them in church or saw them at a school event or something in the community, just commenting on that. You know what, we really appreciate what you did. That snow fence was working well. Thanks for doing it. Those are things that aren't necessarily a monetary compensation, but it is a community affirmation that, hey, you did a good thing.
Great. And we have a comment from Leah Nistier about that, about snow fences. And the comment is, happened to meet a MnDOT coworker while I was in Nicollet, Minnesota. And he said that he was out getting and working with property owners for snow fence methods. I think this was sometime during the COVID dark ages. Very nice to visit with and interesting work assignment. I have a follow-up from Jasmine Dodinger for Steve. AASHTO has now published the ice melting capacity test method TP148. Will you consider using this test to evaluate product performance?
I've seen it. We definitely would consider it. One of the aspects of it is it's not favorable for lots of samples. To do 800 to 1,000 samples takes a certain sense. So even though we may give up some on that wonderful uniformity and comparative ability with the AASHTO method, which is still new, it is better in our sense to get many more replicates to test in uniform, similar conditions in our lab. One of the things with ice melt capacity you have to be very careful of is really you want to compare labs. Labs are not equal on the method. Even the AASHTO method, there are issues with it. TRB, there was a discussion about that 2 weeks ago about how the heat is maintained and how levels are held in the test, particularly as you go cold. So it's an evolving process. It's an easy test to get your head into and a hard one to get the conditions perfect, particularly in real cold ranges.
Thanks. This is a follow-up question for Connie from Charles Bowman on the question of looking at impacts to water and vegetation and infrastructure. Charles asks, did you read the toxicology reports generated for the APL approval?
I would have to say I don't know the answer to that, but all of the literature that we reviewed and all the interviews we conducted are cited in the user guide. So I'm not sure if that was one of them.
Thank you. And then a question, I think for Connie, from Christopher Oaks. Are costs related to chloride removal mitigation calculated in a product cost comparison?
No.
And Carol Zoff has a follow-up question. As a follow-up question, if the reduced environmental harms and positive ice control are the mechanisms for the state support development of a more cost-friendly production of potassium acetate.
You know, one of the things that I'll get on my soapbox just for a minute. So all of these products cause a lot of problems when we use them in massive quantities that we do. I mean, there is no silver bullet and they're going to have side effects any way you slice it. So what I really want us to do is find ways that we can use less. Okay. I've kind of switched over the past 4 years to try to convince like our infrastructure design teams to design better for winter so that the pavement recovers faster and we can stop these repeat offenders like the blowing snow and the meltwater sprawl, things like that. So chemicals is just one of our tools. We've overused it. I think we find ourselves in a jam, but we got to open up our thinking to say, how do we prevent or reduce the need for them? And what can we use in the smallest amount?
Thank you. I have a question for Dan from Maya Hillerud. And it seems like living snow fences would have a lower installation maintenance cost than traditional snow fences. Does one type seem more effective than the other, or are they roughly the same in terms of efficacy?
Yeah, that's a great question. And, looking at the, effectiveness of the snow fence, the structural snow fencing, they are designed and they are installed at the height that's needed for blowing snow control. So they basically will work day one, Whereas if you do a living snow fence with trees or shrubs, you have to, it may take 3 to 4, maybe 5 years for them to grow to that effective fence height. So there is a delay there, even though there's a cost savings per se for buying the plants versus putting up the structural snow fence. There is time involved with it in terms of getting the living snow fence established. And so, at the end of the day, it's probably about the same in terms of the cost. With the standing corn rows, you know, corn can get disease problems and weak stalks. And when we get these real high wind events, those stalks can be, breaking and falling down. And that's where it's really important to have that 30-foot wide strip or even a 60-foot wide strip so that their neighbors can kind of help each other stand up to the wind loads. But, at the end of the day, all of them are tools in the toolbox, and they do provide that flexibility of helping manage the wind. So there isn't just one solution, but it's good to have a diverse solution to maybe find that winning combination that would gain the landowner's trust and interest.
Thank you. Any more questions? Well, this has been a very interesting webinar today. I want to thank our speakers. I want to thank all of our participants for asking great questions. And we will be sending this information out in a follow-up email for everyone. We hope you'll join us for our future watch for our next webinar coming up in February. We hope you'll join us for that and other future webinars. And this concludes for today. Thank you.